explains that. I know there will be an exception. Okay. That's right.
Oui, par contre, j'ai pas de template.
Yes. It's name 45 on the stick. Yeah. Okay, the same thing. Right.
Throw it in.
Well, cool.
Has anyone had Visual C++ Runtime 2008?
It's really quick, yes.
Yeah. I don't mean to.
Are you ready finally? What's up with you? So you should get an exception when you start. Yeah? That's the right thing. If that happens, you're good. What you have to do is go to your user local directory, appdata. So users, Yorex, appdata local. And there you should create a directory that's called VVV. Just an empty directory. if you create just this directory and then restart VLV, it should go. Cat, does it work?
I haven't tried restarting.
So does that work? Yeah, for everyone? Okay. So we'll now just go through the thing, right, from the very beginning. First thing you do, double click the node browser, press V space. And when you press V space, you see all the nodes that are implemented in VL. And for example, we can have a look at this stopwatch node. Just click it, and then you have the VL node lying there. It has this symbol, the squad symbol, which means it's a VL node. Then, if you right-click it, you open up the inspector, the editor, and I just want you to look now at this. We'll just to get an idea of what we have here. Yeah. Easy. Yeah, as I mentioned yesterday already, just to give you an idea, the squad menu is the main menu, and this is the name of the document that is open at the moment. It's the kind of the project of this stopwatch node. Yeah, we have its dependencies. It's depending on basics and integration, but integration is empty anyway. So it's mostly depending on basics, and it's also imported some DLL stuff already. And we see it has one patch. The document stopwatch has one patch that's called stopwatch, and that's the one that's open here also. And you see the implementation of the stopwatch plugin is kind of simple because it just calls another stopwatch implementation, which is you can open it by middle clicking it,
or you can right click on it and say open.
If you don't have a middle click, you right click open. And then you see the actual implementation of the stopwatch. So what you should now pay attention to is that the name of the document has changed up here. Because I'm now in the document basics VL where the implementation of that actual stopwatch is. If I switch the tab back to the other stopwatch patch, I'm back in my document. So you see by switching tabs to look at different patches, you can switch documents. So the document always adapts to the patch that is open. You can have patches open of different documents in the same.
Does changing something in this basics VL stopwatch change it for all stopwatches everywhere?
Yes. So definitely basics VL will be read-only, right?
Okay.
Because it's a super basic library and will not want anyone to change it. You can copy-paste, of course, but it's a bad idea to change anything there. Okay, so up here you just navigate through the open patches and the document adapts always.
What is this red in the corner?
This one? Yeah. That's something we'll come to later. It's not very far developed yet. It's still an ugly little thing. Okay, so this was just giving you a quick glimpse into the editor. We will close it now again with Control W. And before we clone our own template now, it's always a good idea to save the patch where you clone the template in. So I'm saving this. Because now when cloning, it will clone the template exactly in the same location where you saved the patch. So we type v space, then we find the template and control click it and call it something. And we get a node in the patch. And it has an input and an output, and we can connect something here and see what happens. The value just is piped through. Again, with the right click, we open the editor. And if I forgot to mention this before, in the quad menu, the main menu, we see all the open documents. And in this integration situation of the VL pack and VVV, we see that the wave shaper, which was another node in the node browser that was available, right? The wave shaper was available, the stopwatch, and the template. And those three are open documents. They are just here, and we can navigate them. And also the new template I just cloned, my first I called it, is now also just another available open document.
So is it like running?
No, it's not running, it's just loaded.
And if you have hundreds of documents, there will be a list of hundreds
Yeah.
It's provable.
Yeah. Okay, so let's try to patch something now. So the most simple thing we could do is now add a plus node. So we double click. Please don't pay much attention to the node browser yet. We'll go to that. So you just press plus and enter twice, then you get a plus node. output path. And it is kind of transparent. The plus is kind of transparent. That means that it is not running yet, because there is no type that is being declared. At the moment, the plus does not know on which type to operate, and we can tell it which type to operate by attaching a constant here. So we start a link and middle click to create the constant value, and the constant value by default is a float value. So now the whole thing is initialized to float. And you see that when you change the value inside here, outside here in the patch, the value changes. So this is one major difference between VV as you know it and the VL, is that we differentiate between inlets and constants. Remember, in VV you have an I/O box, and you give it a name, and it's the same constant and the inlet. And here it is very much distinguished between the two. You have inlet pads, outlet pads, and you have constants, and you have something for now, something like an output box. This at the moment is just a string display. It's basically a two-string whatever. You can connect it to any data type, and it will just two-string you what's there.
Is there any way to put a comment into the patch?
Difficult for now.
That's good.
Yeah, it's possible, but I'll show you later. Yeah. So, and you see by default, every constant always has a label, and you can change that label by double-clicking it and write something. And so whenever you see a label somewhere in VL, double-click it to change its value. And there's another new thing, that you cannot change values directly on the pin anymore. Every pin needs to have a constant in order to change its value. So this has the advantage that there will be no hidden values somewhere in a patch anymore, right? Yeah. Next thing for our understanding is, what if we connect a spread outside? Connect a random spread. And let's scale the I/O box, the output I/O box a bit. The random spread is not a good choice. I'd rather use the linear spread to get a better understanding. Okay. So I have a linear spread coming in, and you see also immediately a spread comes out, as you would expect. But still, if you hover the pad in VL or any of the inputs, you see that there is not a spread that is arriving. And this is cool, because now we know that the plugin is only operating on a slice, which is very nice, because you can concentrate on the slice operation, and this is like much less confusing. You don't have to deal with bin sizes and stuff. You operate on the slice. Of course, there is a way to get also a spread inside, but the default, this is the better default.
And you can read the three like vectors per image, three slices.
No. If we connect a vector outside, like 3 slices outside, then inside we can declare it as a vector, and we get an actual vector data type. Okay, so this just for your understanding. The plugin itself operates on a per slice basis. Yeah. Next thing. Again about the inlets and outlets. So we call them paths, and we can of course rename them. They have labels, so we can rename them. My value, and you see that the name immediately changes, of course, in VVV. And we can, of course, add any number of paths. And how we do this, there are many different ways to add paths. One way would be to just take a connection and then double-click in this bar, the operation bar, to create another input. The same works for the output. So take the connection and double-click the output bar, create another output. And you can select the paths and delete them again, of course. Another way to create a path is you can directly double-click in the operation bar, and then you have a path plus a connection already. You can connect that somewhere. Or another option is you have a link running, a connection, and you just double-click, and it will create a. You double-click anywhere in the patch, and it will create an inlet or an outlet for you.
Is there any way to edit your links after you've made them?
No.
Yes. I can't come across that.
Yeah, you can delete them. That's the only edit.
There's some mental ones.
Yeah. So the next question would be, when you create a path, what type does it have? Like in VV, you either create an IO box value, or you create an IO box string, or you create an IO box color, and then you know this is a specific type IO box. Here, with all this generic stuff and adaptive stuff, we first say we want to create an inlet or an outlet, and then either VL finds out itself what type it will have, or we can specify it if we want. Like 90% of cases, VL will find it out anyway, and 10% of cases we will want to be smarter and say something specific about it. So, as I showed you in the beginning, as long as nothing is connected, there is no idea of what data type this should be. So the pass node is transparent, it's not in use. As soon as I connect float, the whole graph adapts to being float because there is nothing else around it could fall back to. And also now the input pad is type float. Again, if I disconnect and hover with the mouse, then I see that in the tooltip it says T1, some very cryptic message means there is no type in feared so far. And if I have this situation that there is nothing in feared, no type is being computed, and I still want to specify, because I know that this pad should be a float, then I can middle click it, or maybe even right click the label and press configure. Then this dark black label appears, you double click it, and here you can start typing a type. And you have to know the type, the name of the type exactly until we come up with a pull down here for you to choose the type name from. So for now, you have to type float 32 in like float capital 32. And you see what happens is that the pad is getting this little circuit. And that little circle means that there is a specific type annotated to that pad. So whenever you see a pad with a circle, it means that someone has specifically put a type there. In this case, we can remove it again. The circle is removed. And you see that, I should have mentioned this earlier, you see that the pad is now empty. Empty meaning it's generic. We don't have a type specified. As soon as I connect the constant again, you see that the pad is filled. That means it has a type. It has an automatically adapted type. And as soon as I middle click specify type specifically, it's a filled square with a circle. So we have three states: empty, filled, and with a circle.
Maybe it's not important, but should disconnect the output when you delete the type.
When the type is lost or changed, the output disconnects.
But I don't think it disconnects right now. It doesn't do that. It doesn't seem to do that.
Uh-huh.
Oh yeah, because of this.
But also let's try another type here. If we just so I removed the constant so that we are now again like without any type, and now I annotate this with integer 32. Integer 32. Press enter, and if I now hover the pins in VVV, you see that the pin in VVV has adapted. It's also an integer now. And this should also work with string. No. Doesn't work with string. Okay, there is no string plus. Let's try this. Let's try the RGBA. Is that? Yeah. RGBA is the name of the color type. And you see in VV that the pin is now a color pin.
Why when we have like two inlays like that and one output, it should know the type because I connect the three I got three and it doesn't know. I don't know. Yeah, okay. If I'm like this,
Yeah.
it should know the type because here it's straight and float.
No, the information, the type
type information from outside does not count. Only inside. And inside you have nothing specified. You see, we don't have a color output box yet, but if you place the output box here again, you see that the color value is just written in as a string. And if you change it outside, you see that the value changes inside. Okay. So much regarding how we
Why is the colour doubled when it goes through the plus node? Why is the colour, I've got a colour going in that's white, and it's coming out and it's white, it's 2.
alpha is 2, right?
Yeah.
That's just the implementation of the
red, green, and blue are 2 as well.
Yeah, I guess it's just
I guess it's equal to white on the plus right?
the plus color is just what it does. It's an implementation specification of a plus color. Should it stop at 1 or should it get?
No, yeah, I'm happy with it going over 1.
Yeah, I think it's good.
HDR.
Okay, so much regarding the, we always call it integration. VL is integrated in DVV. And so much regarding how we communicate between the two. We create inlets and outlet paths and define the data types or not if it's not needed. And then we can shuffle data between the two. But we will not focus on this anymore. Now we will mostly focus on the VL itself in the next steps. So I can put this aside here. There is another thing I wanted to say. There is no inspector anymore, but you can have an inspector for the, you still want to configure the constant, and you do this with a middle click, and then you, kind of an inspector pops up there. Again, you get the same with right click and configure. And there you can, this is all not very very much finished, but here you would get the settings that you would use usually in inspector. And it's only available for constants at the moment. No other nodes have any inspector-like features. But so this is always at your fingertip whenever you need to configure the constant, do it there. Okay. Questions so far?
You put 10 on the value node,
This one? No, it's a constant value that cannot be changed other than by you interacting with it.
Derek, is it just the FPS when you move a slider?
What is it?
Do you have the FPS drop down when you move a slider?
Yeah, possibly. Yeah. In the integration, this is we are still in the main loop, right? In the same main loop. Okay, so the next step will be we want to create a new patch. Different ways to do this. You can do it in the document menu and say add patch, or you just press Ctrl P. Now, if you remember what Sebastian was talking about yesterday, we have two different types of patches in VL. We have the utility patches and we have the data type patches. By default, when we create a new patch, it's always a utility patch. That's the lighter one. And you see it, it gets a default name utils. First thing we would want to do maybe is to rename it. We double click the label and then name it something. My operations. And you can check in the document menu, we see my operations has now appeared as a new patch. And as Sebastian also mentioned yesterday, in the utility patch we can only define like simple operations that don't have state, right? And that don't use any nodes that have state. So let's start by doing this and create a little operation. Maybe it's just the simplest thing we can think of is just another plus, add some values up. Speak. Kannst du schauen, ob es da Wasser gibt irgendwo? Yeah. So let's, and the other new thing is that inside one patch you can create multiple operations. Right? That's also a very nice thing now. We'll, for a start, create 2 operations in this new patch, and then see how we can use those operations we just defined in the other patch. So, most simple thing is, again, start with a plus. And it is red at the moment because it says it is not doing anything yet. Create inputs and outputs for it, and I do this by starting a link and double click. Now the whole thing is still red because we haven't assigned it. The thing is still red because we haven't assigned it an operation yet. So this is now not in use still. And for now, the only way. For now, the only way to create a new operation and assign it to the patch is you start a selection, select all the nodes. And then, if you release the button, you get a menu, and it says assign new operation. And then you give the new operation a name. Add stuff, for example. And the whole thing is now placed on the operation add stuff. And also up there in the corner we see that this utility patch now has one operation, and it's called add stuff. So this is just a summary. Up here is a summary of operations in the patch. Let's create a second operation in the same patch. We start, and I do a very simple multiply here. And again, create inputs and outputs. By default, what it does is it would join the 2 operations because it doesn't know that you wanted to create a new one. But again, we can just select the parts of the patch that we want to assign to another operation. Say assign new operation and call it multiply stuff. And now we have 2 separate operations defined in the same patch. And as we see up here, the list of the 2 operations. this is a multiply, so I've just created a multiply. And again, of course, I can rename the operations by double-clicking. And you can have any number of operations here. This is very useful for creating your own little libraries, or even the libraries that we create. We can have a look at one of the libraries here. If we go to the dependencies, basics, for example, I think the range utilities, if you open them, you see that there is a couple of operations defined in one patch.
What did you open for that? What did you open for that?
I went through dependencies, basics, range utils. Just to show you an example of what a patch looks like that has several operations defined. And you see several small little utility operations that you can use. And you would usually group them together if they do something similar, right? They are utilities that deal with ranges somehow. So, but let's go back to our patch.
Is there still a way to just drag stuff and move around while its functionality is when you select? If you select now,
select and then move. Oh, select and then move it around.
Okay, so ignoring the. I thought the menu.
Yeah, you can always ignore this menu. The menu will always pop up at the moment automatically. You can ignore it. Okay, so we have two operations defined in our utility patch. Let's go back in our main patch. And now, as you would do in VVV, when you have created another patch, and you can call the patch, like have the patch as a node appear here. So we double-click and just write add stuff, and see it appears in the node browser already. And also the multiply stuff, it's there. So I have now two nodes that are referencing to the same patch, but to different operations in the same patch. And you see that the two nodes have this symbol here, the 4 lines, meaning that I can middle click and jump to the implementation.
Those two nodes, are they going to be accessible in all the other projects that I create, or only for this one?
Only for this one, because they are available only, you save them in your document. But you can, of course, if you create your own library of stuff that you want to reuse in different projects, then you place them in one document and say, this is my library.
Okay.
And then you place a dependency on that library in your new project.
Okay.
So, no questions, right? This is crystal clear so far, right? No big deal. Yeah. And of course, again, they are gray and transparent now because they are not in use, and if I connect them, there will be inferring a type and work. So what we have created here is actually already some generic operations. You see that the paths by default are not filled. So whatever implementation is available for the plus and for the multiply, those operations will adapt automatically. This will work for a color, this will work for a string, this will work for a float, for an int. And this becomes more interesting when you think of you're creating an operation that, that, like for example, a Boyd's algorithm that does some vector math and separate vectors from each other. And if you do it right, you can create implementations of those algorithms that work for 2D and 3D alike. Like if you're only using operations that are defined generically, then you do this once and it will work for a 2D particle system, and the same thing without any change will work for the 3D particle system. Remember in VUV, as you know it, you have to make something very specific for 2D and then deal with bin sizes and stuff for 3D and stuff. So this was very cumbersome, and now it will work for all types if you do it right. There are, of course, nodes that are very specific to a type, and if you, as soon as you use one of them, of course the whole thing is tied to a specific type. Okay, any questions to the utility patches? There is not much more to say. Utilities, simple stuff. Now, we go back to the utility patch, and we create the stopwatch here. I just double click in the node browser stopwatch, and now stop. You see the stopwatch is available twice. And we'll come to this later. Why? We always take now the second option. Right? And I click the second option, is red. I hover it and read what the tooltip says, and it says process nodes are not allowed in utility patches. Remember what Sebastian was talking about yesterday? There are different nodes. Some of them, those that don't have the bars here, those are the simple operation nodes that don't have a state. And those that have a bar, which you don't see because we don't do the rendering right yet, those have a state inside, so they need to, the stopwatch needs to remember the time and stuff for the next frame. So it has a state. And anything that has a state cannot be used in a utility patch. So we go out in the main patch and place the stopwatch there. Again, just choose the second option. There it works. And here you see the operation add stuff where I place the stopwatch on is also showing red. So again, the errors propagate up in the patch, and you will find it's easy to find errors. Okay. So we understand that we can place stateful nodes like the stopwatch or the LFO or sample and hold, all those nodes, monoflop. We can only place them in patches that are not utility patches. Yeah, I wanted to show you the difference here is so just again to see the difference between how the nodes look. Nodes that have a state have a bar here. They look a bit heavier and nodes that don't have a state, they look a bit lighter. They don't have the bars. It's easy to distinguish them. And it's important, and it's not important, but it's very useful to know and distinguish between stateful nodes and non-stateful nodes. In VV, as you know it, there was not a way to think about it in these terms, right? Because all the nodes look the same, and we didn't mention anywhere if a node has a state or not. And even if you create your own patches, it would be hard often to distinguish, am I using a state here, am I not? And it is just very useful when you structure a program that you know in which parts of your program there is state and in which parts of the program there is none. This is, will help like tremendously in setting up and getting a clearer picture of your algorithm or of the machine you build. If you know that the parts without state are usually much easier to handle. And as soon as state is involved, you have to be aware of where it goes, where it comes from.
It's also referred as active and passive nodes. Sebastian, 2 years ago, he referred to it as active and passive nodes.
Possibly, yeah. The terms are we haven't like fixed on here. We some no that was something different.
Quick question. I open loads of these patches in the future. How do you close them then?
The standard middle click operation, as it is defined in Windows, to close any tab in Windows anywhere, you use a middle click. At some point we might want to add an X there.
What operation? What operation?
And just in any programming in Windows, when you see a tab in the browser or something,
Okay.
you can always middle click it to close it. So we are not making things up here. This is all very much standardized. And also the middle click on the node, to open the node, the middle click, like in VV it is a right click. We changed it here to the middle click because you know the middle click from the browser. When you click a link, it opens a new tab. Same metaphor here. Okay, next. Let's have a look at the node browser a bit. We double click and we see it's different than the one in VV. The one in VV just has a list of nodes in alphabetical order. And here the focus is on the categories. Categories first. Also a new thing, we have cascaded categories now. Like we can have category dot, and the node browser will like have a preview through this. So for example, I don't know what would be a good example. Control, no. Yeah. For example, if you go down and go to the text category, the main text category, you click it, then you see it has two subcategories. One is a character, one is a string. And they'll go in there and you see all the operations of the string and all the operations of the character. And if you're in the character category, how do you get back? You go down here and like uncheck the selection. and then I'm one step back. So this is a bit weird how to get back, because you have to uncheck this. The whole Node browser will get a major rework once we have all the parts figured out that need to go there. At the moment it's quite experimental. We are putting stuff in there just to figure out if it's necessary or not. And so this will see a major rework, the whole thing. But still, the metaphors of navigating will be the same. There will be categories and cascaded categories first. And here you have some buttons to create some of the intrinsic operations directly, but not important for now. Let's go back to the stopwatch and have a look at the two different things here. You see, for now we always created the second entry, and it immediately creates a process node, a stopwatch process node. So the heavy one with the bars. If we click the stopwatch category, if we open it, we see that it has 3 operations. And we can create them individually. We can create the create operation, the update operation, here it's called the reset, and the step operation. We can, instead of creating the process that when you place it creates itself and then has resets and steps as operations available, instead of doing this, we can create and place the individual operations manually. Doesn't sound so appealing because it's more work and you have to connect them, but it does the same thing, and there are cases where you want to do this. And then it is super flexible that you can create individual operations. Think of a particle. You have created a particle, and the particle has multiple operations that it can move, it can collide, it can explode something. Then you will want at some point to call those individual operations dynamically instead of just placing the particle there in the patch and that's it. We'll come to that later.
But can you have a create without the actual stopwatch?
Yeah, but if you call the create, you will create a stopwatch. We'll come to this later. So this, just for your understanding, that the Node browser has those categories, and the last category at some point can be a type in itself. So the stopwatch is a data type that was declared, and the browser shows it up as a category. It's the category stopwatch that has 3 operations defined.
So Yurik, is it like, for instance, if you create the reset iteration,
Yeah.
it's just kind of a pin that says USA?
I think it would be better if we just do it later, right? At the moment, I just wanted to point this out, that the Node browser is structured in categories, and the last categories at some point can be data types that have the operations listed as individual entries. Next, we want to create one of those data type patches ourselves. So what we do is we Control P to create a new patch. And in order to make it a data type patch, what we do is we right click to get this little menu here. And you see in this menu you have 3 quads, 3 little like check boxes, right? And those three checkboxes resample the little checkboxes that you see up here. At the moment they are all not selected, so we have three empty quads here. And as soon we select the first entry to make this patch a data type, we see that the first quad is now dark, so that we immediately see that this patch has state. And also we get for free automatically the two most important operations to create in the update. As soon as you make a patch a data type, you have two operations there. You have the operation create, because at some point this needs to be initialized, and then you most likely will want to have an update operation running. Let's rename this, and I rename it to particle, because now we will want to start creating a patch that resembles the thing that I showed yesterday, this little demo of the particle system. Yeah, but you wouldn't want to. Now, at some point we will have to create some X buttons here that you can just delete them. They're just missing the delete button here. Okay, so let's try to create a particle here. What's the most important thing for the particle is always it has a position and a velocity and stuff. So let's first, how shall we do it? Let's first create a field where we can store the position. How do we do this? We cannot create a field directly at the moment, but we can create a property, an accessor to the grid. And that's even a reader or a writer. So let's start with a reader in the Node browser, click on read, and call it position. Read position. And we see that the listing here has now listed position as a field in this data type patch. So up on the left you always get an overview of what's in the patch. You get its operations and its fields listed. So I have a position reader, and in order to create its counterpart, the writer, I start the connection from here and double click in the patch. Now what I immediately get is created an outlet, but I can at the same moment I get this menu and it can say replace with a setter position. Did you get that menu thing? So you start the connection, double click. By default it creates an outlet, but it also opens the menu. And you can replace to setter. And you see we have a naming problem here, because in the Node browser we're calling it a read write, and here we are still calling it get set. So it's the same thing, but we should of course at some point just use one name here. Okay, so position is the field that the particle, like the state of the particle is the position. And in order to change the position over time, we need to add some velocity. So we add, and where does the velocity come from? It will come from outside. And then, so we call this velocity. Yeah. So we define the field position, and it's red here, and it's added some velocity, and it's written back to the position field. And this is only available inside of the data type. So at some point we want to have access to the position, to the current position of the particle outside, so we also need to create an outlet. Just start the connection, double click, and give it the name position. Let's go back to the main patch. I will clean this up a bit. And we create the particle here. For now, we just create it as a process node once. And let me try different things here. So the position we want to go out to VVV so we can visualize it later. Right? And let's start by placing an I/O box here first. And we get a float by default, and now the particle is just a one-dimensional particle with a one-dimensional position. And if we change its velocity, we see that it moves. Right? Its position moves, the one-dimensional position moves. Let's see if we can make this a two-dimensional particle by changing the constant to a vector constant. We middle-click and annotate the type here. Say vector2, that's the name of the type is vector2. Enter, and we get a 2D particle here. And for the types, yeah, definitely.
Yuri, can you please show again how you switch to it?
Yeah, I middle click to get. Wait, it looks different now. Sorry. So middle click and annotate the type of the constant. You annotate it to vector2. You have to, for now, you have to be very precise with the namings of the types. Later, you will get a pull down and just autocomplete. As soon you do this, you also see that little circle here. That means this is an annotated I/O box. This is like constant. This is now always a vector2.
always what, sorry?
a vector too, unless you change the annotation. But that little circle means that it's like you specify the annotation. Yeah, you see that the particle is now moving in 2 dimensions.
Jumps back to zero sometimes at your pitch too. Is there any reason for this? Like we increase the velocity, it does something, sometimes the values just randomly jump back to zero.
Yeah, I see. That's weird. I'm not sure why.
Comment? Quoi? Quoi dans le sheet? C'est parce que tu définis les flux avec tes particules. Tu les définis par rapport à ton entrée de vélocité. Non? Non, là c'est parce que tu as mis R4, ça fait une c'est comme ce que je disais avec...
Yeah, I saw it.
C'est que Z donc c'est vrai qu'on a trouvé... Ah attends.
We'll observe this. Okay, so we have created a generic particle. It works in 1D, in 2D, and it will work in 3D and in any other dimension so far, because it's very simple. Let us visualize it in VV. So we have different options. We can type out the vector, or we can directly also type out the transformation. Could be easier. So we do a transform 2D. Select its output, and then in VV we create the renderer.
The problem is it doesn't refresh. That's the problem. It's running. If you go up here, you see it actually
Segment.
This one is not invalidating correctly.
And the scaling is, the default scaling of the transform is for now it's 0. It should of course be 1. So scale it here.
Will this be a rule from now on that we can have one value that automatically is assigned to 2 dimensions in this? Because intuitively we would have made one value solid and square.
Yeah. Okay, this is not possible at the moment. At a later point we will add like automatic conversions, and then you can create.
What did you say about
Why is it looping?
the transform? What did you say that you have to scale the transform because in my direct expander nothing shows up?
You set the scaling?
Ah no, okay, thanks.
Is it looping, sorry?
Yeah. Let's ask Elias about this. I'd be curious too. It's not that's not what you would expect. Yeah. So any questions? Yes. That's the next thing. Any more? Otherwise?
Yeah, about the output and input paths, what do you need?
Here, those two?
Should it be reflected in the ODB?
Yeah, it should be. Yeah. It is not. It's a bug. But the idea is, of course, that.
Is there something like constant with inputs so I can visualize them?
This will be it. For now, like constants don't have inputs.
Yeah, okay.
And we distinguish between input boxes and output boxes now. Okay, but everyone has a visualization of the thing and the thing?
I'm kind of broke now.
You broke something?
Yeah.
How?
I tried to put a math code in.
It didn't tell you.
Don't go ahead of yourself. I know. Can't read it.
Maintenant, là, justement, je vais pouvoir faire revenir la partition au début. Ben, il est écrit qu'il essaie de faire un math et que ça change pas. La plus d'écran, l'idée c'est que tablette, c'est faire en gros, ou sinon la moyenne des pourcentages.
Workshops are still sometimes.
Okay, so the next thing I would want to do is to give the particle an initial position, a start position. So that later we can place it with the mouse and like click with the mouse and then it would start there, to run from there. Because at the moment, of course, it starts only at 0. Like 0, 0. So for now we've only operated on the update operation, but I told you there is also always a create operation. And this will be always called for the process node. The create is called once you place the node inside the patch. So as soon as you type no browser particle, the particle goes there, it's initialized. But you can also call it at any point in time if you want. As I said, you can call the operations individually, and then you can just call the create part of the particle, just place it there, and update it at any other time you like. So let's show how we can create the create operation. All I want to do at the point of the creation time is to set the position field, to initialize the position field. So I create another writer or setter for the position field.
Sorry, Jerry, so this partition works like a
Yeah, you can see this as a frame delay here. So I've created a position right, and I want to assign it to the create operation. So I select it, assign to the create operation. And now nothing is happening here because the create operation still doesn't have an inlet where I could specify the position. So I start an operation here, double click, and say, how that would work. So I double clicked and it created the inlet on the update operation. I want to change that, select assign create. Then the inlet is assigned to the create operation.
Moi il est grisé. Ah non, ça je l'ai déjà. C'est quoi Ah oui, position variable.
Na ja, gut.
Oui, il parlait de ça.
So, does everyone have a create?
Can you please redo
The step?
position?
Yeah.
Routine?
I'm deleting this completely and start from scratch. The first thing I want to do is create a writer for the position field. So I say write position. And for me it's now positioned on the create operation by default because I had the create operation active. And then I want to create an inlet for this so that I can set the position. Start a link, double click. It will create me an input on the update operation which doesn't make sense. Doesn't fit together. So I want to place the inlet on the create operation. I do this by right click, assign to create. So we say we want to assign this inlet to the create operation. Right? And this is what happens here. Okay? So now, whenever the particle is being created, I can initialize it to a value. Going here, and you see that there is on this process node now, getting harder and harder to see here. There is a white input pin. So I can initialize the position of the particle. And as you see, nothing happens when I change the constant here, which makes sense, right?
How do you trigger the...
We cannot trigger it in this process world. We cannot trigger it unless we whenever we change something and the thing is recompiled and recreated, then it resets itself in that moment. But we cannot trigger it manually.
How do you recompile? I don't get recompiling stuff when you, because it's on, usually it's when you start the patch.
Yeah. No, whenever you change something in the patch, being recompiled.
Okay.
It has to recompile because the program changed. And then it tries to carry the state from the previous compilation to the next, but sometimes it's not possible. And then it will lose state and initialize the
Seems like it doesn't randomly reset anymore.
The random resets was, I asked Elias, this is when the program loses state. And it shouldn't do this, like when I do nothing. It can happen when you change something on the patch and it needs to recompile, and the old state doesn't fit the new state, so it loses it. That makes sense. But it shouldn't happen when I do nothing, of course. So anyway, I can change the position here, but it doesn't change anything because the create operation is not called, right? Just but still, we have a create operation now where we can set the position initially. And in order to do this, we will now create the particle not as a process node, but as via the two individual operations, create and update, which I mentioned earlier. So I'll show you this process now. So this is the process node. We will leave it here. But now when we type particle, we see that in the node browser we get again the two options. For our own patch we have just created, we now get the process node option, or we get the other option to open the category particle and see that inside there are two operations. And we create them both. First create and then particle update. So whenever we create something, we will have to store it, because otherwise it will be gone. We will have to store it and make it available in the next frame, right? And how do we store things? We use fields. So we want to write the particle we create to a field. So we start a connection here, double click, and say replace with a setter. So I'm creating a particle and write it to a field that is called particle, or let's call it my particle for clarity. So this is my specific instance of a particle that's been created. And on the create operation, on top I see the position input. And the position, I can annotate it again to vector 2. Here I can choose any other position. So now I have. Yeah. Okay. So again, the first thing is I created the create operation, and then I want to save the particle in a field. So I start a connection on the output. I double click. It immediately creates an outlet which I don't want. So I say replace with a setter. And then I have the setter and I rename it to my particle.
Create in the first place.
But
The
to create
create.
a double click particle, I type particle, go to the category and choose create and update. create an inlet constant again here for the position. I annotated to vector 2. I can place it anywhere. So I have
The connection you have white, I have it red.
this one.
Yes.
Never mind. So, at some point the particle is now created and stored in the field that is called my particle. So here we have the particle. What can we do with the particle? We want to update it. So every frame we want to update the particle. In order to do this, we take the input of the particle, double click, and say replace with getter my particle. So that I have a reader, a getter, my particle. It goes in the update, and then again set the particle.
And why are we doing this outside of the actual particle?
Because here we are instantiating the particle. Inside the particle, we are defining its operations, defining how they work, and outside we are applying them. We make use of them. Right? So you write the code and then you call make instances of the data type. So this patch where we're in, it has the idea of one particle, my particle, and it takes it and updates it, does whatever to it, in this case just add the velocity, and then writes the whole resulting particle back to the field, so that in the next frame the game can start from the beginning.
Maybe it would be more easy.
Didn't that already happen inside the particle before?
In the particle before, exactly. So what I'm showing here is exactly the same. It's only a different way to do it. Right?
That's good information. You should point this out before you do it.
Maybe even rename it to particle definition or something and have the full
No,
first
but
as a
that's not true. This is the particle definition.
Yeah, that one, yeah. That's what I mean. Have that as a
Yeah, you.
I don't know.
Yeah.
Particle.
You could do this if it helps you understand. Typically, you don't do this, but because then here you would have particle definition, and that's wrong because that's the particle application. It's the application of the definition here. A node. When you see a node, it's always an application.
Yeah, this is the application, but it contains the definition.
No, it makes use of the definition. It applies the definition. It runs the definition. It instantiates the definition.
But you have it as a sub-fetch so inside it.
Yeah, you can see it like that, but it's
okay.
It's kind of it's an interesting take of seeing things.
In this patch here, the field, my particle, is an instance of the particle.
Yes.
So what does it mean to write to an instance of a particle? Is it a new instance? Like, okay, you have three pointers to an instance in it.
Yeah, this doesn't make sense yet here, right? Because I cannot write to the same field twice.
Okay.
It's not finished yet. Yeah. This is why this one is red. Good observation. This one is red because it says setter of the same name already exists. Yeah? I cannot write to the same field twice in one operation. That would make sense. But okay, back to this, the question. So I should have pointed out earlier. I just wanted to point it out at the very end, but it seems to be important to point out earlier that what we are doing right now is that instead of creating the particle as a process node, we are creating the same particle but through its individual operations. And the two operations of the particle are very limited for now. It's just a create and an update. And so the first step is we create it, write it to a field, store it, and then at every frame update it. Update and write it back to the field.
Can we have only those two without the right one?
We don't need this. Yeah, this is an alternative. It's an alternative use case. And I will come to the point where you see that this is that the left use case is the one you want in this case. Okay, but to finish this, so
how did you get the update patch, the live particle going into it? How did you create that prompt?
I type particle, go into its category and choose update.
Oh no, I mean the little.
What do you mean? So the important step now is that we want to create the particle only once again. As here, when you place the process node, it is created once. And right now, you see that those nodes that create the particle, they are placed on the update operation. You see, this is because they are gray. The update operation is the gray operation. The create operation is the white operation. So we want to assign this part to the create operation. We select it, assign, create. Now they turn white. The links turn white. And this means that this operation is only called once. The particle is created once, written to the field, and that's it. Sorry? Create. It only creates the particle and does nothing to it ever. It's created. And the update will then update the position as we have defined here. If you look inside.
Regarding the definition of it.
That's the definition here. Yeah. Now we are looking at the definition. And the definition says it will add the position to the velocity. And here we have the definition of the create operation. And it says, okay, I will just store the position. Do nothing. So, we are back outside. And this is should now be functioning already. We can take the...
How did you assign this to my particle?
I assign it to what?
Okay, I have a helper. Yeah.
So now we see that the update function has the position output. We take that, put it here, so the transform, and also use the velocity here, and see that this is the same. We can have the particle move.
basically deletes the first particle.
Yeah.
Yeah, I think what was not clear is that we did the same thing another way, but we need time to understand that we did the same thing another way. At the beginning we didn't.
Yeah, I think I said it 3 times now
maybe,
that I'm doing the same thing in a different way. Okay, I will repeat. Now on the screen we see 2 implementations, 2 different alternative implementations of the same thing. One is the particle just applied as a process node, just one node placed in the patch that does 2 things at once. It creates a particle and it updates a particle. This is all done by this process node. The same thing is happening on the other side of the patch, where I'm not using the process node, but I'm using the individual operations that the particle has defined. The particle has defined the create and an update operation, and I'm using them here separately to first create a particle, store it in a field called myParticle, and then use whatever is in that field, apply the update function, and write the result back to the particle.
I'm still confused with instances here, because my particle is an instance of particle type vector 2.
No, the particle is of type particle. My particle is of type particle. Yeah.
So I just wonder if this is a different instance of the object.
I have to think about this myself. Why does it say vector here? Anyway, it's in Fabian, can you help out?
There's any problem? I can help out.
Why does it say particle vector here?
What?
Why is the type of particle vector 2 here? Sorry, yeah, of course.
The particle is generic.
The particle itself is generic, right?
Yeah, exactly.
Yeah.
But
And in this instance, we're using it as a vector 2 particle. Yeah. But
here, from the update output,
this one? Yeah.
is this the same instance than the one going in?
No, it's not.
A new instance?
Yeah, because we didn't touch mutability yet. So by default, everything is immutable.
Yeah.
So if you change the particle, if something changes inside of it, real quick, it will give you a new instance.
Okay,
So you can do multiple connections somewhere else and you won't have a problem. So the consumers won't see different data. Yeah? But maybe in the afternoon we get to this point. I'm not sure. Okay.
But also the thing is that it confuses you because you know too much. But other people will not be confused by this because this is how it always was in VVV. Data goes through and you don't have to understand if it's a new instance of it or not. It's just the way you think about it it's just there is a particle flowing through. So what is the point of doing those 2 different, having those 2 different options? Right? How shall we do this? Yeah. So the problem with the right approach, with the simpler looking approach, is that as soon as I place the particle, it's there, and I cannot recreate it to something. there and it's running. The process is running. Like with an LFO or whatever, it's always there and running, and it's one instance, a single instance. But the cool thing here is that you can run this this create operation. You can run it multiple times, and any amount of times, and you can run it at any time, and create new particles at any time. And that's what we are going to see next. So there are, of course, cases where the right approach is the one you need, but the more dynamic one is the left approach. So I'll remove the right one here for clarity. Now, in order to be able to place some particles at my own mouse clicks, I will now create a mouse input to the node. So I want to have the mouse from VVV, the mouse window, and I want it as an input in the node, and so I need to create an input first, and I do this by creating the mouse state node. And the mouse state node has one input, and I take this, double click to create an inlet. I see the inlet has appeared in VVV. I can connect the mouse. And the inputs are, I get the position of the mouse, and I get the mouse buttons pressed, stuff here. And let's see. Let's say we want to create a particle whenever I press the mouse. So how can I make sure to call this this part whenever I press the mouse? I will select the whole part, the whole create operation. When I release the mouse, it gives me this little menu, and I can say surround this with a loop. Now I have the create thing surrounded with a loop. And what I want is that whenever I press the mouse button, I want the loop to run once. So you know that when it returns, the mouse button returns a 0 or 1. So it will always be 0, the loop will not run. But when I press the mouse button, the loop will execute once.
You don't need like a tog edge on that, or will it just constantly run as it does?
Yeah, it will run as long as I press. Yeah. I can use a tog edge. So now this won't do anything because the operation is now defined on create, and the create is not executed anymore. So I will now assign this back to update. And also I want the mouse position to be used whenever I create the particle. So I take the mouse position, and put it in the, take this as the input. And then I can remove the constant.
Ich glaube, du musst noch Outlet rausnehmen.
Da aus dem, ja.
Sonst meine Loop State.
Yeah. So it is not correct that the field is written inside the loop, because the state inside the loop is its own state. This won't.
Well, it will also have some effect, but not the desired
Yeah.
one.
So I will, in order to get this connection, to get this pad out of the loop, I press the control button, the control key, while dragging it out. And then it's outside. And now I can, I have to create an outlet inside the loop first. Double click. And now what comes out of the loop is, if you hover the output pin of the loop, you see that there is a spread of particle coming out. Because always from the loop, even if it's only one element, it will be a spread. I'll have to consult with Elias on this. Elias, comment ça? Okay, so as I pointed out, the thing that comes out of the for loop is a spread, right? So we have a spread of particles already here, and so far in the field, in the my particle field, we have only it's a single particle here. So we have to, in order to get this working, we have to rebuild the patch so that it already works on the spread instead of a single item. And how we do this is we have to surround this part of the patch with a for each loop, so that for each particle the update is called. Because we're now handling it with spreads, we have to do this. So if you arrange your patch that it looks like this, put the my particle a bit on the side, and then have the update and the transform 2D and the two constants, so that you can comfortably select around them. Yeah, so you only select those nodes, but don't select the reader and writer. So I select this part, release, and say surround with the for each loop. So now this part of the patch is executed for each particle, but we have to do some more steps to get this working. So first, please pay your attention to the outlets here in the for each loop. They have they are triangles now. That's a special form of output. They're called accumulators. We don't need them now. They have been created automatically for us, but in this case they are not what we want. So we can right-click and replace them with an outlet. And do the same for the other one. Replace with an outlet. Now we got some red links. That's that's a new feature here that we, instead of, believe me, instead of deleting links when they don't fit anymore, we just color them in red to show you had a link there and you might be interested in this link at some later point. You maybe just made a mistake yourself. And we remind you that those links were there and they made sense at some point. So you have to actively remove them when you know that you don't need them anymore. But so let's leave them for now, and also we want to connect the output of the transform here of the for each loop to the result. And this output should go to the my particle, which is not allowed at the moment. You see that the particle is not turning green. But we can still force the connection by pressing the control key, because we know that we want to go there. So, and now when we did this, when we forced this connection, the other connection turned red, because it says, okay, then if you know down there what you want to be, then up here I cannot be anymore what I was. But it's not gone. It's just saying, okay, I'm red. I'm not so sure anymore.
The link from output to my particle also turned red when I forced it.
Yeah, okay, for me it's red now too, yeah. Because the situation is not clear yet. Okay. Here we still have a single particle going in, and that's the last thing we have to fix here, that instead of taking a single particle directly in the update, we also want to have a single slice of the spread. And how we do this? We create an inlet here for the for each loop. So I start the link, double click, I get a particle inlet, and you see when you hover the outside of the pad, the pin, it says it's a sequence of particles, a spread sequence of particles. And on the inside of the for each loop, I get access to only a slice. So here it says already in the tooltip, it's only a particle, it's a single particle. And I connect now my particle field to the for each input. And now what I have is the field has now turned into a spread of particles. And the spread of particles goes into the for each loop, which means that for each, as you can read it here, you can read exactly what this does. For each particle, update particle, and then output the particle. So it's very readable. The patch is very readable here. For each particle, update particle, and output the particle. And you see, inside the for each loop, the cool thing here is we only deal with a slice. We can concentrate again on a single slice, do what it has to do, and on the output, automatically this is we have access to the whole spread again. So on the input spread, inside the for each, concentrate only on the slice. On the outside, it's a spread again. So let's see, the result is going out here. It's also a spread of transforms that arrives here. And we can connect that to the segment. At the moment it's nil. There is no element in the spread. It's an empty spread coming out here. So I don't see anything. And now we go back to the initialization where we came from. So we created the mouse input, and whenever we trigger the mouse, we create one particle. But it's one particle, but it's already in a spread. It's all the output of a for loop is always a spread because it can potentially have more than one item. So here we have a spread of particles, and here we have a spread of particles, and we need to kind of find a way to join them, and I think that's the concat. Yeah, the node is called concat. Beware, there are two, and we want the second one, the concat without the spectral version. And then we choose. We have chosen the concat, and then we have to choose from which category. We choose spread, and then we can connect the first spread with the second spread. So, like this. Think of the concat something like there's a cons in VV. It's just concatenating different spreads.
You only have 4 inputs.
Yeah, we don't have dynamic input pins on nodes yet, so this is a fixed amount for now.
At some point there will be.
Yeah. Okay, I made a little mistake here. beware the mouse state node. It has two outputs with a position. One is called the normalized position, and one is called position. Position is in pixel space. Normalized position is in VVV space. So please choose the normalized position to attach to the create.
So why seems to be inverted? Why seems to be inverted?
Yeah, bug. We've fixed this twice already. It's always back to this.
Well, that's why then if you fix it another time. Well, then not again.
So, does it work for you? Does it look like this for you? And does that vaguely make sense now?
There is some confusion between the label naming and the function. Because sometimes they create, maybe just lowercase the labels.
Which one? Which one?
Like create.
This one?
Is that a function or is that just that function?
The create is a function of the particle. As the same as the update is function of the particle. Any questions?
Could you repeat how we create? We type in particle and then choose create from. Yeah.
Parce que les positions directes à l'inverse.
By connecting this output box here, you can see that there is, whenever I click in the renderer, this number of slices in the spread increases. Now I have 10 slices of particles in my particle field. So do you already get an idea of how this could help you, like in creating dynamic instances of things that don't have to be particles, can be anything, of course? You're not?
I'm lost since the beginning.
Oh, that's bad.
Following. But
Okay.
it's okay, it's my fault. I had no time to prepare in advance.
Okay. You have another chance the other day. So I think the next step that we could take is, right now it's a bit stupid because all the particles move in the same direction. But what would be interesting is to give each particle not only an individual starting position, but also an individual random velocity, right?
Actually, I would more be interested in the rest
In what?
in the rest option, because it's already more than some
Yeah.
here. Somebody already got like 6
reset option, how could you implement it yourself now, the reset?
Well, I thought you restarted the loop.
Restart the loop?
Yeah.
But the loop is restarted whenever I press the mouse button. Then it's run.
Okay.
When I don't press it, it's not. So the loop does only insert and add more particles. But how could we get rid of some particles?
Is it possible to like get my particle and produce equal 0? Because my particle is a variable, so you can make it equal 0 at some point, or
To do what?
the my particle, I don't know how you call that.
This field?
Yeah, this field should be
to reset it. To initialize it. Yeah, of course. That would be an option to set the field to an empty spread, and then you have it reset. Yeah. How would we do it? I think it should simply work with the switch here.
Yeah, with the switch, right.
So
just need one frame with the equal to 0.
you see? I've simply put a switch here, and as long as the condition is false, the switch goes through. Just I can add more and more particles, but when I switch, the particle field is overwritten with nothing, with an empty spread, and then I have it reset. Ja, es sind invertiert. Bug.
How did you make the condition? How does make the condition?
It's just a middle click on the link. Creates you a constant. And here again, it's a toggle constant, and you can middle click to configure it to a bang. Yeah. This is just a normal constant value. So you start with a connection here, middle click, and then you can middle click to configure it to a bang. So I want to finish on this idea to get each particle initialized with a random velocity, right? Because right now, if you have a look at the patch, the velocity is only set here at update time. Whenever we update the particle, every particle gets the same velocity. But we want to have each particle to have its own velocity. So we will want the particle to be initialized with the velocity, and the initialization of the particle is in the create part. So up here is where we want to specify a velocity, and we do this by going back to the definition, of our particle. We haven't been there for a while, but this is the definition of the particle, data type. And we see that it just takes in a position on creation time. Now we want to take in a velocity as well. So double click to add a new pad, call it velocity, and just write the velocity to a field, and put that field on create. And name that field velocity. That was fast. So that's the result how it should look like.
Could you redo
Yeah.
just for the interface?
Yeah.
Slides.
I redo this. Yeah. I double click the operation bar to get an inlet.
Okay.
I rename the inlet. It's called velocity. I start a connection from the inlet and double click, and it will immediately create me another outlet which I don't want, so I replace it with a setter. I only have the option position now, it doesn't make sense, so it's red at the beginning because there is already a position. Double click the name, set it to velocity. Now I see that it is still not white, so I select it, assign, create.